And today we're going to start with the isosceles triangle theorems. Okay? And so we've got these sheets that we're going to go over. If you have some notes, you can write on your notes. If you like a notebook or if you save the sheets, you can do it on there, whichever you prefer. The first one is that the isosceles is the isosceles triangle theorem. Now, what's the difference between a theorem and a postulate?
A theorem can be, it's not totally proven, like...
Yeah, it can be proved deductively. You can prove that it's true.
A postulate is...
It's something that we have to assume to be true in order to solve.
Right.
Okay? So something we state is going to be true. Okay? All right. So we can prove this theorem. It says that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So let's prove it. So here is... Okay. So it says that if two sides of a triangle are congruent, so let's have a triangle, we'll call it A, B, C, because we like that. So if I have triangle ABC, and it says that if two sides are congruent, namely if AC is congruent to...
Oh wow, recalibrating.
I don't know, this never does this to Mrs. Novikis. I don't know, I must do something weird when I walk by her. Alright, so if AB is congruent to CB, then the angles opposite these sides are also congruent. Well, these are the opposite sides, right?
Wait. I thought it said.
Did I? Hang on.
It says on the paper if line segment AB is congruent to line segment AC.
Well, I didn't pick. I just named my triangle. I'm not doing it off the sheet. I'm just proving that the theorem's true. You can do it with anything else. And before I do that, I'm sorry. I should probably go over what an isosceles triangle is because I assumed that. So here's an isosceles triangle. The base is the side that is not the same. Your legs are your two sides that are the same. Your vertex angle is opposite of your base, and your base angles are opposite of your legs. So when we talk about legs and bases and vertex angle and base angle, so we know what we're talking about. So the vertex angle is opposite the base, and the base angles are opposite the legs. Now let me ask you a question. This is a, what kind of triangle is this?
Isosceles.
All right. So what? Let me ask. What kind of triangle is that?
Equilateral.
Is that also an isosceles triangle?
No. Yes. Well, it can be.
Who thinks it is? Who thinks an equilateral triangle is always an isosceles triangle? Okay, good.
But an equilateral triangle cannot be. You mean an isosceles triangle cannot be an equilateral triangle? It's like one.
An isosceles triangle can be an equilateral triangle, but it doesn't have to be.
Right, right. One can be the other, but the other doesn't always necessarily be
Let's
that.
say it like this: an isosceles triangle. An equilateral triangle is always isosceles,
Right.
but an isosceles triangle is not always equilateral.
Yes, that.
How's that? All right. So back to what I was talking about. So this wasn't on the sheet, so I'm just using different letters. So if they said something different on the sheets, I'm just going to prove it to you based on what I'm drawing here. Okay. So I have, this is my given. So I have two sides, and then the theorem says that angle A is congruent to angle C. So can I prove that?
Yes.
Okay. How would you prove that, Sam? How would you go about proving that?
Angle A is congruent to angle C. Well, let's see. Those two are congruent. So
You may not see this at first, so this is kind of tough, okay?
bisector.
So that means I'm going to draw that, right?
So okay. And then if it's a side, okay.
Hang on.
Got you.
So I'm going to draw an angle bisector here.
It looks a little bit different in this one. So you have two going off.
Yeah, I'm not even using that one. I'm just doing my own. So, and I'm going to call that D. D is going to be the midpoint of my base, AC, and it's going to bisect angle B. Okay? So, what do I know about angle ABD and angle DBC?
They're congruent.
Why?
Based on the angle definition.
I'm sorry, because of what?
Definition of bisector.
Definition of an angle bisector. Okay, so if I have, this is congruent to this, and this is congruent to, these are congruent, and these are congruent, then what can I say next?
BD is congruent to BD because of the reflexive properties. And you have a side angle side.
Very good.
You could also do
I was enlightened.
AD is congruent to DC.
Say that again.
You could also do AD is congruent to DC. So you get that.
And you could,
Because of.
hang on. I'm trying to follow. Go ahead.
AD.
You could say that these are,
Lines of, yeah,
well, how does that help you?
because it still works.
Because then I have a side, another side, and a not included angle.
You got the angles in the bottom.
No, that's what I'm trying to prove. I want to prove that those are
prove
congruent.
it, okay.
That's why I don't know
I
if they're
thought
congruent.
they
or not.
already proved.
No, I just put it in green because that's what I want to try to prove.
Okay.
Okay? So BD by the reflexive. So now I can say the triangle ABD is congruent to triangle CBD.
Yes, sir.
And through what postulate?
Congruent, triangle,
No, what postulate says those triangles are congruent?
Oh.
The,
That's it. No,
no, I don't know.
not sure.
Side angle side, right?
Oh,
Side
sure.
angle side.
So, okay.
Alright. Now that I have these two triangles congruent, now I can say angle A is congruent to angle C because of CPCTC. Because now everything's congruent. Once I have all the corresponding parts are congruent. So I just proved you that this is true. So that's how, so if you have a theorem, it's true. So you'll know now, from now on in the future, you don't have to prove all that in your proofs. You can just use the isosceles triangle theorem, because you know that's true. And that says that if two sides of a triangle are congruent, then the opposite angles are also congruent. So in other words, if you have a proof, you don't have to go through 6 steps that. You can just say, if you have this, you can say these are congruent, and the reason why is the isosceles triangle theorem.
Where was this a week ago?
Well, that's, you can't use them before you use them.
Seriously.
All right.
Everyone's gonna pass that test. Yeah.
All right, we'll hold off on these for a minute. So let's look on our sheet real quick. It's on page number 47 at the bottom. So number 1, say line segment AC is congruent to line segment AD.
Oh, got it.
What are the congruent base angles?
Angle C and angle D.
Well, those are very ambiguous.
Wait, where are we?
We're on page 47, number 4.4, the very first worksheet on the front.
F and G.
Number 1 says AC, as you're looking at this example triangle, right? The one's got like 6 different letters, or 8?
Yeah.
All right. So AC is congruent to AD. So Sal, what are the base angles that are congruent?
C and D.
Yeah, but C's got 4 different angles there.
I get what you're saying.
All right.
Ambiguous now.
Okay.
ACD and ADC.
Good. Does everybody see that?
Yeah.
All
I
right.
was like,
Jordan, number 4. GD is congruent to DE.
Alright, the base angles DGE is congruent to DEG.
Hang on a minute. GD is congruent to DE. And just give me the 2 angles again.
DGE and DEG.
Yes, good. All right. Go down to the bottom to number 5. It says, given 2 congruent angles, name an isosceles triangle. So you're going to name the triangle and its 2 legs. So Molly, number 5, angle STU and angle SUT. So what's the triangle that's isosceles?
Triangle STU.
Good. And what are the legs?
Legs are ST and SU.
Good. Everyone see that?
Hold on, could you go a little bit slower? I'm sorry, I'm like trying to.
It's all right.
wait, I don't see. I don't get them.
Here's the.
I don't see me.
So here's your triangle, and then it's like inverted like this, right? S T V W X Z Y U. Okay, so it's saying that STU, this angle here, is congruent to SUT, this angle here. Okay? So it's asking what's the triangle? Well, that makes this whole triangle isosceles. Triangle STU. And then what are the congruent legs? Well, they're here. ST
Oh.
and SU.
Okay, that makes sense.
Oh, okay.
That's what they're asking, okay? All right, Annie, how about number 8? Angle XWZ and angle WXZ. What's my isosceles triangle?
The isosceles triangle would be triangle XWZ.
Good, XWZ is your triangle. And what are your two congruent legs?
Okay, and the two legs would be WZ and XZ.
Good. All right, any questions on that part? We'll go to the back page of that. All right, now we need some other things. So I don't think these are on your sheet, or maybe they are, but
I don't think they're there.
two sides, two angles of a triangle.
Can you write this down?
Yeah, because I don't see these written anywhere on your sheet, so
Oh.
they're in your book, but I would write them down because I don't see them on your sheet. That way you have them written somewhere.
Oh, the calories?
The corollaries. What is a corollary?
An equilateral triangle is also
No. It's, oh, is there like a lot, a rule?
It's what it is it's a statement that you can use to be true because of a theorem that was proved. So it's part of the theorem. So part of the isosceles, what do we call it? As part of the isosceles triangle theorem, these three things can also be said about it.
So it's like a brick to build the theorem?
These are the bricks in the bricks in the theorem. Well, if the theorem is true, that means all these corollaries have to be true. If the theorem is true, which we proved true, then these all have to be true as well. That's really what it is. Corollary means by the way. Corollary means and also. From the Greek, corollanus, meaning to add. Okay, so it adds to the theorem that we have. So these are pretty common sense. So that once we have that theorem, an equilateral triangle is also equiangular. So if you have an equilateral triangle, that means all the angles are equal. And we know that there's 180 degrees in a triangle, so if all the angles are equal, then we know an equilateral triangle has to have 360-degree angles, because 60 times 3 is 180. And then finally, the bisector of a vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. Okay.
Wow. Wow.
So the last one means if you have like a triangle and you have a bisector in the middle of it, then these two sides would be 90 degrees.
Yes, absolutely.
That's what it means.
Yep, and not only does it tell you that, but it tells you that the place where that bisector meets the base is the midpoint.
Okay.
You get two pieces of information. I'll just give another minute for them to finish copy. Two done. Okay. All right. So let's do a couple of these on the back. So notice, let's try number 9, Sal. What will I do? So it says find the value of x. What would I do here?
Number 9. So,
I'm sorry.
Yeah.
Are we using these definitions that we just got to help us know what the answer is to this?
I have some of them, yeah. I don't think you need any of those for this one. but-
algebraically, 3x
Yeah,
minus 2 is equal to 16.
Why do you know? How do you know that?
Because the angles are, it says it's equal angle here.
Because you have two congruent base angles, that means these sides have to be congruent. So yeah, 3x minus 2 equals 16. And that's simple, right? 3x
Yep.
equals 18 and x equals 6. Okay. How about number 10, Michael?
Let's see. Well,
Aren't
doesn't the two bottom angles are both equal to 65, right?
Yeah.
So 65 plus 65 plus x equals 180.
What is 65 plus 65?
Let's see, 130.
Good. All right, Annie, number 11.
Okay, so they would be 5x and x plus 20 are equal. So it would be 5x plus x plus 20 equals 180. So you get 6x plus 20.
No. They equal
Where
each
am I?
other, don't they?
Oh,
Yeah, where am I at?
sorry, they equal. So it's 5x equals x plus 20. I'm sorry.
That's all right. So then you subtract an x from each side.
So you get 4x equals 4. So you get 5.
Okay, number 12, Sale.
Okay.
What am I proving?
So 80.
Ooh, wow. I have
X equals.
Well, 80 plus x.
All right, pay it. Where you want to start with is look what you have that you know are congruent. If those are congruent, what else is congruent?
The angle.
These angles, right?
Yeah. Wouldn't they be the same? So okay. So 80 plus 2x equals 180 minus. So it's 50.
What? Oh, okay.
Stupid. Why didn't I think of that? See,
I
if I
thought
were to,
that,
okay.
I thought that the bottom equals
Yeah, I get it. I get what you're saying. I get it.
Which one?
Flip the triangle in.
Yeah, the triangle doesn't have to be. Notice these are the congruent, so it's the opposite angles that are congruent. Doesn't matter where they. You can flip it upside down or backwards. That's not going to matter.
So the answer
So the next thing is
is 180 equals x plus 2x.
I'm sorry. Say that again.
180 equals 80 plus 2x.
Yes. All right, number 13, Annie.
Okay. So I think the opposite blank angle, that would be x.
Okay.
So you get 5x equals 180. So that would be
Oh, 3 times
36.
30, 36. Okay. All right, Molly. Actually, I think I skipped Michael. Michael, number 14.
Whoa, okay. Oh, well, two angles.
I think you can solve this, right? Pretty simple.
Okay. Where do I start? Well, this well, the two angles on the side have to, the sum of those two angles has to equal 100, right?
Has to equal what?
100, right? Exterior angle.
No. But make it as simple as this. This whole angle here
Oh,
has to be 180, right?
Okay, yeah.
So what's
I see.
this one?
That's 80.
And then this is 80, right?
Yeah.
So what do you got?
Okay. So it'd be 40 would be x. Wait. 20. Yeah.
20, right?
20. Sorry.
Subtract 160.
Yeah. Okay.
Okay.
Uh,
I see.
All right. Annie, number 15.
Okay. So I think that the opposite, that's actually the opposite side of, yes, that'd be x. And then the top angle would be 90. So you do 2x plus 90 equals 180. So that would be 2x equals 90. And that would be,
Good. Molly,
Um,
number 16.
the two inside corners would be 180 minus x because on the line, you would have full angle, so each angle would be 180 minus x, then you get 360 minus.
360?
Because 180 plus 180, then you minus 2x.
You're right,
equals
but I think
50.
you're gonna confuse people because you're making that way more complicated than it has to be. You're
Wait,
right,
can I-
you're 100% right. Well, how would you do it?
I would do 50 and then just put y's in the corners.
Right, these are both equal, right? You can pick any letter, right?
Yeah.
So 180 equals
Y's.
2y minus 50, or plus 50, right?
Yeah.
So 2y equals 130, y equals
65.
65. And so these angles are each 65 here, right? And then to find x, you just take 180 minus 65,
115.
right? The way you did it is 100% correct. I think people will get confused if I do that on the board. But your thinking is not wrong.
What did she do?
She did this way. She did 180 minus x for both those angles.
Oh,
And
okay.
then subtract all from 360.
Be 65.
The external angles, which is still correct. I just didn't want to confuse you guys. All right.
That's it.
How about this one, Jordan? I saved the hard one for you, Jordan, since you did so well on the test. You were the
Wait,
ace.
we're not doing number 7.
We could. They'll take a little bit, but.
That's okay.
All right, Jordan. Find the value of x.
Which one? Oh.
This is number 18.
Wouldn't it be like,
Yeah.
is it right? Process.
Take your time. Sure.
My word.
What do you know about, if these are the same, Jordan, what do you know about these angles?
But those are the same.
The opposite of the same. And then this is a vertical angle, right?
Yes, those equal 70.
And so these, all four of those are all the same, right?
Yeah, they're all 70. And then x equals 72.
X equals 72.
No. X
70 as well?
Yeah.
I don't know. Let's see. Let's see. So how do I find out what those angles are?
Well, you know that they're equal.
You got it.
Let's call them something, okay? Let's call them y, okay?
Yeah.
Because 2y plus 70 is 180, right?
Yes, sir.
Okay. 110 equals 2y. So those angles are 55 each, right? So these are 55 each, right? Yes?
Yeah.
Yes, sir.
Okay. So what's this one?
That's 55 as well. Wait, no. Wait. Just a thank you. 70.
Right, that's what you said from the get-go, right? Because if those are the same, then we went to 150.
I just made one biggest mistake calculating.
Number 19, who's up? Sale, number 19.
Oh, yeah, yeah.
I guess those are parallel. So, 62.
What do I need to solve? 62 is x.
What's the
X
x?
equals 62.
Okay, how do you know?
Because you can do alternate interior angles on the 62 to the bottom right corner, and then from
Well,
that,
hang on. All right, alternate interior to this one here?
no, left, bottom left.
The
Yeah.
this
Well,
thing?
on the other side.
This
Yeah.
one? Alternate interior to this. So you're saying this is 62?
Right.
Oh.
And that's
And
like,
then
this
that's-
is 62.
And then
because
you do
those are
the
congruent.
alternate thing up to the top.
So 62 and 62 is 124.
Yes, sir.
180 minus 124 would be 56, right?
Wait,
That's, this angle's 56,
So
right?
62 plus
And if you
56.
took 180, which is a straight angle, minus 110, 108, is how much?
how did you get?
Oh.
Did I add something wrong? 60,
It's 118, not 108.
10, that's 120 for this, right? Instead of 108?
Yeah.
118.
was 118.
And you'd also
62 and 50.
Yeah, it's 118.
112
Yeah,
is 118. Okay.
118.
You also
Okay.
know.
All right, and that leaves you 62, right?
You'd also know it's 62 because of alternate interior.
Right.
Yes.
Alternate interiors with this.
That's what I was gonna say.
Okay.
Wait,
Okay.
how did you do that again?
He didn't move me away.
How did, like, I know how you got 62,
Okay.
but you 62 plus 60 plus, like, y equals 180.
Oh, I didn't have a Y. I don't.
Well, no, because you have to find the top angle.
Well, once you have parallel lines here, once you knew what this angle was, that's got to be the same for alternate interior.
Oh.
I just showed you could also add them up to 180 at the top because a straight angle is 180. So on a lot of these, there's more than one way to do them. Okay, let's see. All right. If two angles, so here's a theorem, and I think this is on,
15 and
yes.
yeah.
So this is the next page, 49. So this theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So I think I can prove this to you because this is a theorem. So let's see. Okay, and I'm going to call these, I'm going to also call this A, B, and C. So it tells me that if I have two angles of a triangle that are congruent, so if I have this, if angle A is congruent to angle C, can I prove that AB is congruent to CB? Who thinks I can prove that? Well, it's a theorem, so I can. All right. But let's, how would I go about that?
Without the theorem.
Right. Well, how can I prove to you that that theorem's true? So this is all I'm given, right? I'm given that those two angles are the same. So if those two angles are the same, what do I'm saying that these opposite sides are the same. Those are congruent. But how can I prove that?
You do the angle bisector,
Yeah.
and then you get that.
Well, that was why before I did the two sides, I was proving the angles.
Oh,
now
now
I'm
you're
doing
just
the
showing
back
us the
side.
other way of doing it? The other...
Well, I'm proving you that this theorem's also right. Okay.
Yep, okay.
So what does that tell me?
But you could call it D.
Yeah, I'll call that D, where it meets there. And then what? That's not quite straight, but that's fine. So then I know what?
That ABD
ABD.
and CBD are congruent.
Those
based on
are.
The angle bisector, the definition of the angle bisector.
Okay. I'm not sure how that helps me, but okay, you can say that. Then what?
So if you know that those two are congruent,
You can't go anywhere with that once you know they're congruent. But it was a good, that's still true. Those are congruent.
If we're getting points
But-
for tree, you just got an extra
But
tree
how about
point.
this one here? We know that BD equals BD. That's reflexive property. So I have a side and I have an angle here. So,
And you know it's a midpoint,
what?
right? Isn't it,
Right, the
bisected?
corollary said that if you bisect it, it meets at the midpoint. That tells you these are the same, right?
So then you have an angle side angle. Yeah.
Well, where's your other angle?
The 90.
Right, here's your other one. So if this is 90 degrees, this is 90 degrees. That's the definition of perpendicular. And so then you can say triangle ADB is congruent to triangle
CDB.
CDB. And what's your reason?
Oh, ASA. Right?
No.
Why?
SAS, right?
Side angle side or angle side angle?
Where's your, what angles are you using?
Oh, we have to prove the A and the C? Again?
No, this is what you were given.
Okay, can't we use,
The 90 degrees.
the 90-degree
So you're
angle?
using angle, side, angle. You could do it that way. Or you did I did the reflexive, so I did side, angle, side.
Oh, okay.
Either way
Yeah,
it works.
either way works. Okay, I'm
Once you have congruent triangles, now you can say that BA and AB and CB are congruent because of what?
CBCTC.
Good. All right. So now from now on, anytime you're given two angles that are congruent, you can say the opposite sides are congruent, and all you have to say is, and it didn't name it? I guess not. You just you have to say if two angles of a triangle are congruent, then the sides opposite are congruent. And there's a corollary to that. That says an equal angular triangle is also equilateral. So if all of the angles are equal inside, all the sides are equal as well. They're all the same measure. Okay. So on to our sheet. Now we have some proofs. Okay. We're on page 49 here with the proof at the bottom. We'll start with you, Jordan. Line segment AB is congruent to line segment CD, and AD is congruent to CD. What's the reason?
Wait, which one?
Page 49, number 1.
Line AB is congruent to line CD.
Yeah, and AD is congruent to CD.
Alright.
I'm saying that's true. I'm asking you why. What's the reason? That they're giving you that that's true. What's the reason?
Yeah, I'm trying to be.
What's the first reason on most of your proofs?
Oh,
It's given, yeah. Okay. Notice up above there, it's given. All right, Sal, angle 2 is congruent to angle 4, or the measure of angle 2 is equal to the measure of angle 4, and angle 1 is congruent to angle 3. Okay? So what am I going to use for my reason for that?
If would it be the thing that we just talked about? If two sides of a triangle. Wait, we didn't prove it congruent though, right? We're trying to prove that angle So we can go with the thing. Wait. If the two, yeah, wait. Let me think this through for a second.
It's the first theorem we learned today.
Right. It's
The
like when you say
isosceles-
the two farthest angles are the same because of the other angle.
No, I'm saying that if two sides are congruent, then their opposite angles are congruent. That was the isosceles triangle theorem that we learned today. That was the very first theorem we did.
The isosceles one? Yeah. What
Right.
was that?
The isosceles triangle theorem says that if two sides are congruent, the opposite angles are congruent. Okay. Now, for 3, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Angle addition postulate. Good.
So good.
You blew my mind.
And then number 4, the measure of bad equals the measure of
Big. Big.
what?
BCD.
BCD.
So then would that be reflected?
And what was the reason?
There's
And I'm sorry, BCD.
BAD.
BCD. BCD is equal to BAD, right?
So then would that be could that be reflexive?
No.
No, they're not the same things. Bad's not the same as BCD.
Well, I wasn't sure if you like put a parentheses around that and said this equation is equal to this equation and this equation is equal to this equation. You're squishing.
Okay, what is the reason for that?
I feel like it's substitution, but I don't think that's correct.
Well, that was the last step.
Yeah, it's the last one.
No.
Reflective? Yeah.
No, it's not reflexive.
No.
Oh wait, no, this is substitution twice, isn't it? I'm sorry, I was looking at the last one. Yeah, look at you have measure of angle 1 plus the measure of angle 2. Those are the same things as measure of BAD, right? That's the
Substitution.
yeah, that's substitution. We just changed the measure of 1 plus the measure of angle 2 for BAD.
Ah.
So those are the same things. And then what's my last step here, Michael? Number 5 for my statement.
Measure of angle BAD is equal to measure of angle BCD.
Good. 46. What time is this? I have a few.
I don't know. Whatever you want to stop.
I got 5 minutes. Well, I'm going to go on to the back page. It says number 50. On the very back, page 50. I'm going to do number 4. Okay.
Keep flipping sides. Yeah. That's the
Oh,
big
Hey, I bet you given this first.
All right.
That's okay.
That's fine. Okay, Annie, what's my first? The first step says AB is congruent to AC, and what's the reason for that? You like those?
Do we have a triangle to look at next?
It's on the back page, so unfortunately I have to flip. Michael, I have angle B is congruent to angle C.
Oh, is that the, I don't know what to call it. Is it the, isosceles thing? Yeah.
Isosceles triangle theorem. Okay?
Here.
Because that says if you have two sides that are congruent, the opposite angles are congruent. Step 3, Sal, angle B is congruent to angle 2. And angle C is congruent to angle 1.
The unknown, I guess.
The unknown theorem?
Yep, that's what I'm gonna go with.
Try again.
Wait, aren't they the?
Angle B is congruent to angle 2. Angle C is congruent to angle 1.
They should be the same angle.
Look at your given information.
Oh, it is given? I don't even see that. Where is that? Oh. I couldn't see that.
Okay. Number 4, it says through substitution. So I'm going to substitute something. So angle B is congruent to angle 2.
So you substitute. Wait, so if B equals C, then 2 must equal 1.
It's saying B is, oh, from the previous statement, B is congruent to 2.
And C is congruent. So you substitute B for 2 and C for 1 for angle 1, so you get.
Huh?
Is that right?
Well, so what do you get?
Measurement of congruent measurement. Or just angle.
2 is equal to the measure of angle 1. Okay, substitution. AD is congruent to AE. Jordan. I hate flipping back. AD and AE. Okay. No, that said if you have two sides, then the opposite angles are equal. You want to say if two angles are congruent, then their opposite sides are congruent. That was our second theorem?
Could we just put the isosceles theorem, or no?
No, that's not the same. The isosceles theorem says that if you have two sides that are same, the opposite angles are equal.
Oh, I thought
This says if you have two angles that are congruent, then they're opposite sides. So it's the opposite, okay? And is there one more here? Oh,
Definition of
well,
isosceles triangle.
that's just the statement. ADE is isosceles. What time was that? 1 minute? Okay. So your homework is up on the board.